You're asked to solve for theta, or the angle, in each triangle. So in this one here, we are looking for these small little angles here. We need to know SOHCAHTOA because that is going to help us because we're going to be able to set up this equation. I'm going to use sine for this one because I'm looking at the opposite side here and the hypotenuse. So sine of theta, or this angle here, is equal to the opposite over the hypotenuse. Now I can just kind of plug this into a calculator where I'm trying to get rid of sine and leave us with just theta. So I'm going to do sine -1, sine to the power of -1, or the inverse of sine to both sides, which gets rid of the sine here, and I'm left with just theta. And then I just got to plug this part into my calculator just to make sure that you're on the same page. Be careful because let's say that you're in a graphing calculator and you get an answer like, let's see what you would get if I plug in this here. If you get an answer like 0.289, be careful because your calculator is in radians, where if you want the answer in degrees, you'd have to go to the mode and change it to degrees. And then when you plug that in, it'll give you your actual answer of 16.6 degrees for that angle. Now the second one here, I'm looking for this angle. I have the adjacent side in the hypotenuse, so I'm going to use cosine of theta equals the adjacent over the hypotenuse. And now, same thing, I'm going to do the inverse of cosine to both sides, which gives me the angle equals the inverse of cosine of 10/12. I plug that into a calculator, which I'm not showing you on the screen right now, but just know that I'm doing it. And I get about, these are about, they're not exact because I'm rounding them, but about 33.56 degrees. And those are our angles.